Hello, today I'm continuing the review for the test on Thursday or tomorrow. I'm going to be doing some graphing questions with sine cosine functions and also do some cos and sine law questions as well. So first up, the question is graph the function y equals 3 cos 4x plus pi plus 2. So first I like to write down all of all the values that we have. So first off, we have our a value or our amplitude. So amplitude equals 3. Then next up, in order to get our k value, in order that we need to find our period, we have to factor out the value in front of our x value. So it'd be 3 cos 4x, and then pi divided by 4 is pi over 4, double bracket, plus 2. So that means our k, so you don't have to write these letters, it's a preference thing. So k equals 4. So that means the period equals 2 pi over k equals 2 pi over 4, which is pi over 2. And now we have our phase shift. So we have our c equals pi over 4, and our phase shift equals negative c equals negative pi over 4. But what you can also do is this, that x equals pi, or wait, sorry. There we go. X plus pi over 4 equals 0, so x equals negative pi over 4. And then next up we have our vertical shift, or our d value, and that's plus 2, so that means that there is a vertical shift of 2 up. So how I like to do this, I like to kind of sketch my transformations on the graph. So first I'll draw some axes here. And it's also really important to choose a good scale. And when you're choosing a scale, it's good to look at your period. So our period is pi over 2. So I like to break things into quarters. So I would do, so pi over 2 divided by 4 would be pi over 8. So I like to break things into quarters. It just makes graphing things really simple. So I'm going to do increments of pi over 8. Then we'd have pi over 4. Then 3 pi over 8, then pi over 2, then we have negative pi over 8, and then I like to draw the vertical shift. So we're basically moving this x-axis that we see here up 2. So I wouldn't draw it as a solid line, but just as like a dashed line. So let's just do it with this. So this like dotted yellow line, that's basically where our x-axis is. And now this is just my way of doing it. If you have a different way of doing it, do whatever works best for you. So we know our amplitude is 3. So the amplitude is how much it goes up and how much it goes down from the x-axis in this graph. So this has an amplitude of 1. It goes up 1, down 1. But our new x-axis, not really, but for the graph at least, is this dashed yellow line, our vertical shift up. So what we can do, we know our amplitude is 3. So I like to just do a little bit of a dashed line, so I know this is the highest point our graph will reach, and then down 3 here, and this is the lowest point it will reach. And then how I like to start this is at the phase shift. So we know our phase shift is negative pi over 4 to the left since it's negative. So let's choose a color. Let's do pink. So we know our graph starts at negative pi over 4. So this is a cos function. A cos function starts at its maximum. So at negative pi over 4, we will be at our maximum here. And then what I like to do, so we know the period is pi over 2. So if we count out pi over 8, another pi over 8, pi over 8, pi over 8, I'm trying to think of a better way of counting that out. So we have 1 pi over 8, pi over 4, 3 pi over 8, and then finally pi over 2 right here. So we know a cos function starts, one cycle starts at the beginning, and then it ends, it starts at its maximum and it ends at its maximum is what I'm trying to say. So that means our graph starts at its maximum and ends at its maximum. And then we can continue to sketch this pattern out. So we know the period is pi over 2. So every 4 dots is where the maximum is. And then another thing we know is that exactly halfway between the start point and end point of one cycle, our function crosses the x-axis. So and by half I meant a quarter. So yeah, so if we break that into another half, that's why I have it into quarters. We know that here and here it crosses the x-axis, or in this case, it crosses y equals 2 because we have that vertical shift. And sorry, what I was trying to say, exactly halfway between, it reaches its minimum here. So I'm going to put our minimum right here, and same thing over here. And then we just connect the dots. Oh, should have one. Sorry, there's made a mistake there. If I add that dot. And that's how you can graph a cos graph with transformations. Alright, next up we have a sine function here. So I'm going to start by writing our values. So our amplitude is 2, but we also have this negative here, so that means there is a vertical reflection. If this hasn't been covered in any of your other lectures that I've been able to attend, or in any of your homework, I would just ignore this part and not stress about it. But if it has been covered, then yeah, don't worry about it then. Okay, sorry about that. So there's a vertical reflection across the x-axis. So this basically means that every point is mirrored. Our k value is just 1. So that means that our period just equals 2 pi because it's just going to be divided by 1. And we have a vertical shift upwards because of that plus 2. So I'm going to do this in a similar approach. So I like to draw the vertical shift. So it's up 2 units. So this is basically our new x-axis in a sense. technically not correct, but that's just the way I like to think about it. Our amplitude is 2, so that means our function will go 2 above our vertical shift and 2 below our vertical shift. So I like to just do a little dashed line to sort of box it in. And then let's do our scale here. So I always like, if it works out, to get our period, so our 2 pi, and then just divide it by 4 for our our increments for our x-axis. So we have pi over 2, pi, 3 pi over 2, and then 2 pi. And then let's do that the other way. Alright, and then we don't have any phase shift, so we can just start at the beginning. And what I'm going to do, since we have a reflection, just to make it a little bit simpler, I'm just going to draw it without the reflection first, and then I'm going to invert it. So I'm going to just write y equals without this shift here, just to say what the color is. So a sine graph, it starts at the middle. It starts at the x-axis, or in this case, it's been shifted upwards. It starts at this point, and then so 1, 2, 3, 4. That's our period, is 2 pi. That's why I like having it divided in quarters. So it starts at the midpoint and ends at the midpoint, and then also halfway between it also reaches that point. And then a quarter into its cycle, it reaches its min, and then 3/4 in, or sorry, a quarter in it reaches its max, and 3/4 in reaches its min. And then we can just sort of repeat this cycle. So 1, 2, 3, 4. Then we can just sort of sketch that. But since there's that reflection, we have to invert all the points. So all these points that are already on the x-axis, or not the x-axis, on the vertical shift up, will stay the same, because if they're mirrored across this line, they'll stay in the same spot. But now we just invert these peaks. So instead of being at a maximum here, it's now at a minimum. And instead of being at a minimum here, it's now a maximum. Do the same over here. And this is our new graph. If you want, you could erase the other graph, or you could leave it on. But if you leave it on, make sure you say you label your graphs. And that's how you sketch a sine graph. Next up, we have some cosine law. So I'll just move this over. So from what I heard, on your test, you'll be given one of these formulas for the cos law. I mean, they're all the same formula, but they're just rearranged in different ways. I was looking for a formula sheet, but I couldn't find it. So yeah, if you do have your formula sheet and you know what formula you have, make sure you're able to rearrange to the other formula. So there's one formula here that is arranged to find the side length that we have here. And then there's another formula that is arranged to find this angle C, which I'll show you how to do in a second. So we're trying to find a side length X. So that will be our C in this case. So these two angles are grouped together. So this will be our, let's switch colors. This will be our, we can call it theta, doesn't matter. Theta, and this will be our X value, which is C in this formula, which is a little bit confusing. And then these other two side lengths, doesn't matter which one is A or B. So X, which is our C in this case, is the square root of A squared plus B squared minus 2AB times cos, and I'm calling that angle theta, the opposite angle to the unknown side. So that would equal the square root of 15 squared plus 19 squared minus 2 times 15 times 19 cos of the angle theta, which is 26 degrees. Make sure that your calculator is in degrees mode if it is in degrees. I'm just going to put this entire thing into my calculator. I get X equals approximately 8.58, say, units. It doesn't give us any units. And so yeah, that's how you use cosine law to find an angle. Depends what formula you're given. I'd imagine it'd be this formula, or it would be C squared, and all this stuff here wouldn't be under square root. Not entirely sure. But next up we have an angle, and we don't have we don't have our formula rearranged to find the angle. So the first thing I would do is rearrange this. So we have C equals the square root of A squared plus B squared minus 2AB cos C. Let's first get rid of that root because we're after this the C here, that's the angle. So we'll square both sides. So C squared equals A squared plus B squared minus 2AB cos C. Now we're trying to isolate for this, so we're going to subtract. So C squared minus A squared minus B squared equals negative 2AB cos of C. And then we're trying to isolate this cos C, so we'll divide by negative 2AB. And C squared minus A squared minus B squared over negative 2AB equals cos C. And now you just have to inverse the cos. So second function cos in your calculator. And your formula might look different depending if they divided this negative out or not. They should be the same. Equals C, and that's our angle. So in this case our angle is X, and our side length, we can just call it C, is the side length that is opposite to our angle. That's just the key part of setting this up. So now we just basically put that into our formula here. So the A and B doesn't matter. So, well, it matters, but it doesn't matter which one you call A and which one you call B. So C equals cos negative 1 of our C squared, so the angle, or the side length opposite to our unknown angle, which is 16 squared minus 8 squared or 22 squared, doesn't matter the order, divided by negative 2 times A and B, which is 8 times 22. And, sorry, this cos is over all of this. So I'm just going to multiply this out. So this is the negative cos, or sorry, inverse cos of 73 over 88, which equals 30, approximately 34 degrees. So yeah, that's how you do one of those problems. So that wraps up that video. I wish you guys best of luck with your test tomorrow. If you have any questions, feel free to let me know. Thank you. Goodbye.